Okay, let's move now to problem number 3. Using rational exponents. It's about planetary motion. Kepler's third law of orbital motion shows how you can approximate the period p in Earth years it takes a planet to complete one orbit of the Sun. Use the function p equals d raised to 3 over 2, where d is the distance from the planet to the Sun in astronomical units, or AU, about 93 million miles, or the distance from Earth to the Sun. Now the question is, how many Earth years does it take Mars to orbit the Sun? Given is the distance, which is 1.52 AU from Sun to Mars. First step, write the formula. What is our formula? So it's already given in the problem, and that is P equals D raised to 3 over 2. D stands for the distance. What is our distance from our given? That is 1.52. Now substitute for D. So 1.52 raised to 3 over 2. Next, simplify. What is 1.52 raised to 3 over 2? Yes, and that is approximately 1.87 or 1 and 87 hundredths. So, it takes Mars approximately 1.87 Earth years to orbit the Sun. Okay, got it number 3. Kepler's third law of orbital motion shows how you can approximate the period p in Earth years it takes a planet to complete one orbit of the Sun. Use the function p equals d raised to 3 over 2, where d is the distance from the planet to the Sun in astronomical units, or AU, about 930 million miles, or the distance from Earth to the Sun. Find the approximate length in Earth years of a Venusian year if Venus is 0.72 or 72 hundredths AU from the Sun. I'll give you 10 seconds to answer this question. Timer starts now.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Time's up. Let's check your answer. Okay, the formula is P equals D raised to 3 over 2. What is D, or distance, in our given? Yes, and that is 72 hundredths. So we have 72 hundredths raised to 3 over 2. Now write that in radical form, and that will be square root of 0.72 raised to 3. Now simplify. What is the square root of 0.72 raised to 3? Yes, that is approximately 0.61 or 61 hundredths. So the length of a Venusian year is about 0.61 Earth years. Problem number 4. Combining radical expressions. Before we proceed to our discussion, let's watch this video.
In this problem, you will combine radical expressions. What is the fourth root of x cubed divided by the eighth root of x squared in simplest form? The radicands are different, but both are powers of the same variable x. Write the expressions using exponents. Use the definition of rational exponent to rewrite the expressions. Use the division property for exponents. Subtract the exponents. 2/8 reduces to 1/4. Simplify and then write in either exponential or radical form. So, the simplest form of the original expression is x to the 1/2 power, or the square root of x.
Okay, let's answer got it 4. Question. What is square root of 3 times the fourth root of 3 in simplest form? I'll give you a chance to answer. I will give you 10 seconds to answer this question. Timer starts now.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Time's up. Let us check your answer. What is the first step in solving this question?